Okay, so hello everyone and welcome to this video. And today we're going to discuss about modular arithmetic. And so we're going to discuss about modular arithmetic, and we're going to try and see how to solve problems such as these. So here the problem basically asks you to divide a number, a huge number such as 3 to the power 997 with 7, and try and find the remainder when you do that. So this is a very standard problem that is often found in competitive exams, especially in India, because I have studied in India, and so this I know is a very common problem in competitive exams across India. After your 11th and 12th grade, often sometimes this kind of problems also appear in competitive exams after your bachelor's degree, and it's kind of often seen as a very usual problem that happens to occur in competitive exams even after your bachelor's. So this is a very important question, and often people try and kind of find easy solutions to this problem, and the most easiest solution to this problem can be found only if you know modular arithmetic. So but again, this video won't be as such a video containing a lot of stuff regarding modular arithmetic, so we won't go into much details of modular arithmetic, but we will only discuss some basic stuff regarding modular arithmetic. So what is modular arithmetic? So one notation that is very much a known notation in modular arithmetic is this notation, and so we often see this kind of notation where something like this is written, and this is often said as A is congruent to B modulo M. So when you say A is congruent to B modulo M. And so now the question is, what does this mean? This basically means that M divides B minus M. And another very important question that might be asked here is, what is A, B and M? So A and B are integers. Any integers, can be negative, can be positive, and M is positive integer. So this notation is very important, and if you know this notation and a few basic properties involving this notation, which we will discuss now, then basically it's pretty easy to kind of solve problems such as trying to kind of find remainder of after dividing a very big number by another number. So basically trying to understand this notation is very important for us, and this is basically the basic of this notation, where you have this thing, and then after that you kind of, so how to say what these things mean. You say A is congruent to B modulo M. So this is how you kind of say that entire thing, and what that entire notation means is basically M divides B minus A. That is what it means. And a very crucial and important part is to understand that A and B can be any integer, and M is a positive integer. Just to know this is very important in order to kind of use this notation. And now we will go into like understanding some basic properties of uh, this notation and some basic properties of modular arithmetic are like this, and all of this are basically are kind of given considering that a, or rather I can write it with some other color. So all these notations are basically considering that a is congruent to b modulo m, and then it's kind of easy to see that if a is congruent to b modulo m, then if c is any integer, if c is an integer, then a plus c is congruent to b plus c modulo m. Because if I do b minus a, then basically b plus c minus a plus c will be nothing but b minus a. And since by the definition of the property we already said that we assume that a is congruent to b modulo m, then b minus a is already divisible by m, so this thing has to be divisible by m. Another basic property is like saying that okay, so like considering c is an integer again, we can say that basically a c is congruent to bc modulo m, and like it's very easy to understand why, because if I do b minus a, then what I get is this thing. And as it again, like we know that we have already seen that the problem definition of, not the problem definition but the property definition already mentions or assumes that a is congruent to b modulo m, so b minus a has to be divisible by m. So if b minus a is divisible by m, then this thing is also divisible by m. So these two properties are like very basic properties. Again, another property which is like a very important property, and especially like extremely important in order to kind of so another very important property, and like which is a very important property, and like the property which we need to kind of understand in order to solve that problem that we wanted to solve in this video, is basically this last property, which says that if n is any non-negative integer, then a to the power n is congruent to b to the power n modulo n. And it's also easy to see, because if I try and do b to the power n minus a to the power n, then we all know that one of the factors of this thing is b minus a. So one of the factors is definitely b minus a, and since we know that a is congruent to b modulo m, then b minus a is already divisible by m, and so b to the power n minus a to the power n will also be divisible by m. So these are the very basic properties of like modular arithmetic, which one needs to know in order to solve problems such as finding remainders and all of that. And later in some of my videos I will also be discussing about some more important theorems related to modular arithmetic, which will use these basic properties of modular arithmetic, and we'll see that these are like very important properties. Also there are a couple of more basic properties, but at this moment I don't think that it's necessary to kind of discuss those properties, because I mean, for the problem that we are kind of trying to solve at this moment, I think these three properties are kind of absolutely essential, and if we kind of know these properties, we will be many problems which are related to the problem that we are kind of trying to solve today. So if we kind of go back in order to try and solve this problem that we have defined today. So one important thing to understand is 3 to the power 3 is going on to minus 1 modulo 7. And why is that? If I see that minus 1 minus 27, since 3 to the power 3 is 27, so this is minus 28. So my b minus a is minus 28, which is always divisible by 7. So then I can write this thing that 3 to the power 3 is minus 1 minus 7. Now the important thing to note is basically how can we reach this power, or how close can we reach to this power. So clearly, like any number that's divisible by 3 should kind of get us very close to that power. At least we can kind of try, since we are trying to raise the power of, or if we are kind of trying to use this thing, this property, which is property 3, then basically we will try to raise the power of this entire thing. And in order to raise the power, we will try and raise it to such a number that basically is very close to this number. So if I kind of do this thing, then I can write this. And now we know that 3 times 332 is 996. Now going from here to here is basically by using property 3, or rather this property. And now from here I can write that okay, this is 3 to the power 996, which is equal to 1 modulo 7, because raising minus 1 to an even power should be plus 1. And now if I use the second property, I can multiply 3 on both sides, and this I can do. So basically, like from here to here, if I'm going, then basically this I am doing by using the property, or using the fact that AC is connected to AC. And now clearly we can see that okay, if I kind of evaluate this, then this is 3 to the power 7, and that is going to 3 modulo 7. And so we can say that the remainder, then 3 to the power 997 is divided by 7, is 3. So the remainder should be 3. So I hope this was very instructional for people trying to appear for competitive exams, or even going for jobs, and or like trying to give any interview exams. And I will try and bring solutions to many more such problems, and hopefully this will help the people who are preparing for these kind of competitive exams, aptitude-based exams, or anything as such. And I will discuss more stuff related to modular arithmetic in my next videos. And I hope that you like the video. And if you like the video, then please do actually like the video, and if you want to share the video with your other fellow students, friends, and I hope this helps. So thank you, and hope you have a nice day.